Take it away,
Cool.
man.
Yeah, so I think I'm good to go. I will just set my laptop and right. Fine. Again, thank you guys for having me and giving this opportunity to share my talk. So my talk title is basically Shift Left with DevSecOps scanning every single code change. So before going into the depth of the topic, let's understand. Let me introduce myself. Myself Avinash Jain. You can find me on Twitter and Medium with an handle as logicbomb_1. I'm into InfoSec field for past 5 years, for more than 5 years right now. I'm a cybersecurity speaker. I've been speaking in various conferences and meetups. I'm an active blogger. You can find my blogs on Medium with handle as logicbomb_1. I've been actively writing on various stuff around InfoSec, DevSecOps, data breaches, and data privacy issues. I usually in my free time is try to break application logics, try to bypass them, and this is something which keeps me motivated to learn various things. I've been recently featured in various news magazine and articles. Recently got covered in Forbes, BBC, ZDat, TechCrunch for the work that I do in InfoSec, for the type of data breaches and data privacy issues that I find. I've been acknowledged and honored by companies like Google, NASA, Yahoo, European Sun government, US, and UK government as well, and some of the top companies of India. So this is about me. No, but before jumping into the title of the topic, the first two words, basically the first two words of the talk is basically shift left. Now, before moving into the depth of the topics, let's understand what that word means. What is shift left? So let's get into the general meaning of shift left. So all of us have seen a red light in the traffic, turning red, traffic lights turning red to stop us from parking, from crossing the road. Have you ever wondered why only the red color being used to stop the vehicles in the traffic light? And again, you must have seen a rainbow, coming in during the rainy and sun season. Have you ever wondered why only the red color comes at the last of the rainbow? Why the color red always comes at the end of the rainbow? So the scientific reason behind is that because the red color has the largest wavelength. So because the red color has the largest wavelength, it travels to a larger distance. Hence it comes at the end of the rainbow. So it basically means when you move or when you increase some distance, you are moving away from the source, and that is you are moving towards the right side. You are moving to the red side. So whenever you bring something close to the source, that is when you move to the left side. That basically means you are shifting to the left side, and that basically means you are shifting too close to the source. So this is what generic meaning of shift left is. Now coming to the term, what shift left means in computer world, in technology. So when you bring your security process in your Azure cycle or in your release process as close as to your developers or as close as to the source, it basically means shift left. So when you bring your security testing, your security checks, your VAPT, pen testing, all kind of those security workflows as close to the developers or as close to the SDLC cycle, as close to the starting of the SDLC cycle, that means you are shifting left on the cycle. That means you are shifting left in the complete process. So that is what we mean by shift left in the DevSecOps. I hope we must be aware of what DevSecOps means. I think there have been talks in BSides itself when people when speakers are told about what DevSecOps exactly mean. So it brings me to a quote where I quote that security should not be treated as an afterthought. So what traditionally happens that security always comes at the end of the cycle. How companies release their product or how companies release their features, functionality is that after everything is done, after the code is deployed in production, after the release has gone to live, after the feature has gone into production, then the security testing start happening. Then security team comes into picture. They do security testing, security checks, VAPT, and all kind of those checks. What brings me to this? What bring shift left basically means security should not be treated as an afterthought. Security should not be taken as something which people can assume that it can happen after everything happens. Why? The reason why we should not treat security as an afterthought. Why we should bring security as close to the developers, or why we should bring security at the starting of the SDLC cycle. This graph clearly shows that what is the cost if we are doing security testing, or if we are involving security checks at the end of the SDLC cycle. So suppose how typical SDLC cycle looks like is basically but first of all information gathering happens, then product team with the developers, they design the feature and they ship it to the developer develop the feature, and then it goes to QA does the QA testing, and then finally it goes to infra team for the deployment and production. And at the last stage, the security teams comes to test the feature from the security perspective. Now what actually happens is that suppose security teams find some vulnerability. Now what will happen, that vulnerability or that code fix will again now go to QA will test it, and then it will again go to developers. Developer will have to fix it, and then basically the complete cycle is now getting repeated. uh, Now again developer has to fix that code, it will again go to QA has to test it, and then it will come to security teams to check for the security vulnerabilities. So what actually happening is here is that when we are involving security checks, or when we are involving security testing at the end of the cycle, we are doubling our effort and we are doubling our time. We are actually repeating the SDLC cycle again and again. So that what this graph suggests. So the graph shows that as we move the security away from the source, or as we move away from the source, the cost of security, that is the cost of fixing of a bug, or the cost of patch, increases rapidly. So this is what the consequences of if we do not bring security close to the source, or if we are treating security as an afterthought, that's something which can be done after, or it can be deprioritized by the team. This what makes security testing more important and more critical when we want to involve security testing or security checks as close to the developers, or as close to the source, so that we can basically reduce the time and effort that we are spending on fixing a bug after the release has gone live, or after the features has gone into production. This brings me to the core of the talk. Basically, in this talk, I will be showing you how basically we at my company, how we have achieved this, how we are now scanning each and every PR or each and every code change that goes to GitHub or any GitHub repository, any code repository, against all the security checks. So now what we have actually is done that every change or every code change, every PR that developer raise in their branch, that actually goes through a continuous security checks. They goes through a regular and automated security checks. So at the end, we don't need to wait that PR get mastered and the future get deployed to production, then security checks are going on. Now we have brought down the security checks within our code repository. So within the code repository that we are using. So anytime now, any developer or any QA, any engineer raise any PR, or they make any code commit, our continuous GitHub code hacking happens. It basically checks the commit against different kind of security checks that we implemented. So this is basically how the architecture of the tool that we have developed, or that we have that we have developed in the company. So this is the basic architecture, how it looks like. I will again come to this picture and will tell you how it actually functions. On the top, from the top of it, I will tell you that our product name is basically called G Shield, which basically again symbolizing the GitHub Shield. And there's a backend app, which is our core backend application, which is running and performing various kind of security checks. This backend app is also integrated with Jenkins to pull the to pull various CI/CD pipelines, and it also have a salary queue to basically basically pull various kind of if there's multiple PRs going, so it will be parallelly pulling from the salary queue to process them. So I will be again coming to this architecture to explain you how it exactly happens. So how we have actually done is that GitHub provides an extensive feature of creating a GitHub app. So in GitHub, you can create your own GitHub apps. Now this GitHub app can be integrated with any of the repository that you have in your company. You can integrate your GitHub app with one repository or with two, or you can also integrate your GitHub app with all that repository that your organization have. And on the top of it, you can restrict this application to have access to some limited functionalities or limited commits of that particular repository. So you can provide access or read access to this app, so that this particular application will have only read access to listen to all the PRs. You can also give comment permission, so that this particular application can comment on the PRs if you want to make it more user friendly. You can also configure this app to basically send all the events that it is getting to a web to the webhook, to an outgoing webhook URL. And this webhook URL is basically the heart of this complete tool, which is the continuous GitHub code hacking. So what actually happens is that whenever any event is triggered, the GitHub app, because the GitHub app is now integrated with all that repository in your company. So and when any repository has any change, has any code comment, this GitHub app will listen to it, and because it has an outgoing webhook, now it will send all those all the event that it hurts, it listen, it send that HTTP postcard to that webhook. Now this webhook can be used for various purposes. This webhook is basically highly customizable. It has various checks. You can build your own checks. You can use this webhook to trigger an issue tracker. You can use this webhook to trigger a CI build, or even you can use this webhook to deploy any changes to your production servers. And as I said, this checks this basically this webhook URL, which is basically bringing some other benefits of having a modular and customized checks. So you have now you can build, as I said, you can build on top of it. You can build your custom checks. You can have modules so that they're independent of each other. If one of the security checks are not able to get performed, the other will function as it is. Other will function with their full capabilities. It is highly automated. Every security check is automated. Whenever someone raises any PR, this webhook will listen to those events and send those events to the backend app, which performs all this kind of checks, security checks, which performed automatically. Now I will tell you how it basically functions at the backend. So you already configured a GitHub app. You created a GitHub app and give it and basically configured it within a webhook URL, and that webhook URL is basically your backend app. So you have your backend app running. You can code your backend app in Python or go in any language that you want. Now what basically happens is that when anyone make any changes to any of the code repository, because that GitHub app is listening to every code base, it is listening to every repository, it will send the post event that it has listened to the webhook which is now configured on the backend app. And now backend have multiple security checks, have multiple modules which perform security checks on the event that he has listened. So suppose someone raised a PR and that PR contains a Docker file. So you have written a module in the backend app which checks basically if the webhook if the webhook had received the event and that event contains a file with a name Docker file, that means someone is trying to build a Docker image. And then your module comes where it performs a check, like it can perform a Docker file linter, or because it is a Docker file, it will also have various kind of a Docker statement like from, copy, add, and it must be having if you're mounting any sensitive mount points, it will also have that Docker command in the Docker file. So you can now create a module which can check whether that Docker file is containing any sensitive mount point or not. You can even after you come to know that PR contains a Docker file, you can also perform a linting on the Docker file. And similarly, we have built something which is called through which we check whether anyone in the company is using a Docker file which contains an image which is not a trusted image. So what we do is basically when this webhook get the post event, and our backend app checks whether the event contains a file with starting name as Docker file. If the PR contains a file which is Docker file, then it checks the first statement. The first statement is basically the from statement. from where your base image is basically getting created, and it checks whether that image is lying into the whitelist list that we have. So we have a dynamic and very customized checklist of Docker images that which contain all the trusted, all the verified, and all the official images that we use in the company, and also all the official images that are in the Docker repository like Ubuntu, Red Hat, on all those images. So this is how it basically works. The backend app listens to the events. That event is sent by the GitHub app because it is configured with the webhook. And then on the in the backend app, we have created custom checks which perform Docker file enter, which perform checking for sensitive mount point, which also checks whether your image is an authorized Docker image or not. And also we have built other other checks. You can basically, this complete backend app is highly customized. It is highly modular. You can build as amount of check that you want, as many as checks as you want. We have created more checks. Like we also check whether any PR which is raised is contain any hard coded credential or not, for which we are using open source tool like Git Secret, which is an open source tool by AWS Labs. So we also check whenever anyone raises any PR, that PR contains any hard coded credentials or not. And then we have a Jenkins. This backend have also integrated with the Jenkins to basically, if you want to trigger any deployment, if suppose all the checks are passed. So if you want to trigger any deployment, so if suppose any checks fail, suppose your PR contains any hard-coded credential of your AWS or of your config in your config file, then you can trigger a Jenkins job which basically just fail the deployment. Or basically you can also comment in the PR itself saying that because they are security check which has failed, so you cannot proceed to get it merged to master. So this is so in a note, these are the capabilities that we have built. Now this app, which is this tool which is known as G Shield, performs SAST scanning, which is static application security testing. We are using SonarQube for doing static code analysis. It also performs DAS, which is a dynamic application security testing. We are using open source tool of OFZAP to perform DAS scanning on the PRs that being released. We are also checking whether the requirement.txt file contains any dependencies which has external vulnerabilities, which has any OpenCV or which has any high or critical vulnerability. Again, using OF's ZAP dependency plugin in Jenkins. And then this is something which we are creating now. So we checks whether whether the PR contains any Docker file, and that Docker file has using the images which are lying into the list of whitelist that we have created in house. And then on the top of it, there are additional capabilities that we have created, like secret detection. We run Git Secret to find if someone hard coded any credentials into the PR. We also perform Docker file lint, if there's any Docker file being pushed into a PR and that Docker file is not up to the standards. So we use header lint to perform Docker file linting. And as I said, we also check against the base images that we have in house. So this is how basically a generic PR looks like. So whenever this is a screenshot taken when someone raises any PR. So when any engineer raises a PR, this is how our G Shield works. So it basically comment in the PR itself, just like a code review. Just like everyone do a code review, they comment that this you are not following standard or something like that. Our G Shield app itself works do a code review and comment just like a human user. So if you can see, it first tells that security analysis or security checks has started. There has been no secret in that particular PR, so it is saying that there's no secret in your PR. Sonar code analysis, it basically performing static analysis on the PR, and if there's any high vulnerability, it basically just says that there's P0 vulnerability and there's a full report where a developer can access a full report. And then it also perform a Docker file linter. So this particular PR contain a Docker file, and because we have a customized check which checks whether any PR contain a Docker file or not, and then it performs a Docker file linter. So this is basically commented to a developer who raised the PR to basically make changes in the Docker file according to the standard, or basically according to the result that our linter has given out. So this is how our GitHub application, our GitHub tool, which is known as G Shield, works like. So we can also so in the initial we have started in a non-blocking mode. We don't want PR getting blocked and developer are not able to push their commits into the master branch. So initially we started with a non-blocking mode. So this our tool just comment all the security checks which has been failed, and now it is up to the developer to basically fix it or not. So we wanted to bring that proactiveness within the developers, and after we find that developers engines are now are able to understand what these security checks mean, then we want to bring that proactiveness within the developers to fix those security issues. You can also make it in a way that if any of the security checks get failed, you a developer or no one cannot merge that PR to master. You can also make those changes. So this is the benefit of this complete GitHub application, of this complete tool that we have coded, which is known as G Sheet. So now all the security checks is being performed whenever any PR is raised. So now we don't need to wait when a PR is raised and it is merged to master, the feature is gone to live, and then we are doing a security checks. Now within whenever any engineer or any developer is raising any PR into their dev branch, all the security checks are performed as and when. So now the developer don't need to wait for security team to perform those checks. These checks perform automatically. So one of the beauty of this tool is also automation. Everything is in an automated manner. A developer raise a PR and all the security checks are performed automatically. This is highly flexible. As I said, these checks are highly modular and customized. You can add as many checks as you want in your backend app. You can add as we have integrated secret detection, we have integrated Docker image scanning, we have integrated Docker file inter. So these checks are modular. You can add as many checks that you want and make it more customizable. So these are the improvements, or these are benefit that our tool brings to basically bring security close to the source, which basically brings me to a concept of the title that we have, that is shift left DevSecOps, where we are shifting our security checks as close to the source, where we are bringing security checks or security testing as close to the source. So now we don't need to wait any features going live, and then we are bringing security checks, or then we are bringing security testing and security team to perform those checks. Now everything is in a way that we don't need to wait, and we also don't need to think that security is an afterthought. Everything is done whenever a developer any raising any PR, and basically we are getting the result as and when. The cost of fixing the bug is also very less, because now the checks are being performed in the developer branch itself. Now developer is getting to know that their checks or their PR contain any hardcoded credentials, or their PR has any static code analysis vulnerability or any dynamic vulnerability. So they now come to know about those results whenever they are developing or whenever they are writing their code. So this is basically now preventing a lot of time and effort that earlier being spent when the releases are going live and then security check or security testing being performed. So this is the beauty of this tool. These are the benefit it brings when you're bringing your security, or when you're bringing your security to the close to the source, close to the developers. So that's it about this talk. If you have any question, you can shoot it out. Here are my credentials. If anyone want to DM me, I'm highly available on Twitter with handle as logic_1, and you can also shoot out my mail. Mail to my mail ID. It's being given here. Yeah, that's it.
Thank you very much for that. Sorry, I'm just using the wrong camera for a second. There we go. No, listen, Avinash, thank you so much for that. That was amazing. I'm just looking through for any questions from the audience.